Hello there, and welcome back. It's so good to have you here with us again. Tonight, we're going on a rather unusual journey, a journey that begins in two places at once, separated by centuries and oceans, but connected by a strange and wonderful thread of imagination and evolution. We're going to explore the quiet genesis of a pixelated predator, a childhood icon known to millions, and its remarkable real-life counterpart, a botanical curiosity that baffled the greatest minds in science. We're telling the story of the Piranha Plant from Super Mario, and the impossibly strange, impossibly real Venus Flytrap. If you enjoy what we do here, these quiet explorations into the wonders of the living world, I'd be so grateful if you'd consider liking this video, and perhaps subscribing if you feel this is a place you'd like to return to. It really does help our little community grow, and as always, I love to know where you're listening from. It's a beautiful thought, all of us around the world, settling in together for the same story. But that can wait. For now, the only thing that matters is your comfort. So find that perfect spot on your pillow. Let your shoulders soften, take a slow, deep breath, and let it go. We're about to dim the lights on the world you know, and travel back in time, first to a quiet room in Kyoto, filled with the gentle hum of electronics, and then further still to a steamy Carolina bog, 2 centuries earlier, where a plant was waiting to turn the world of biology completely upside down. Chapter 1: Pixelated Predators and Carolina Curiosities. In the early 1980s, in the city of Kyoto, there was a kind of quiet magic being made. It wasn't the magic of ancient temples or rustling bamboo groves, but a new kind, brewed in unassuming office buildings under the warm glow of cathode ray tube monitors. This was the headquarters of Nintendo, a company on the verge of changing the world, and inside, a young artist and designer named Shigeru Miyamoto was not just creating a game, he was building a world. He was a landscape architect for a kingdom that would exist only on a silicon chip. The world of Super Mario Bros. Was being sketched out on graph paper, one block, one mushroom, and one perilous gap at a time. Imagine that room, the air thick with concentration, the faint, sweet smell of warm plastic and electricity from the humming consoles. The clack of keyboards is the only percussion. The world outside is one of high-speed trains and bustling city life, but in here, the scale is microscopic. The canvas is a grid of pixels only 256 dots wide by 240 dots tall. The palette of colors available is shockingly limited, a tiny box of crayons compared to the infinite spectrum of the real world. Every single element, from the hero himself to the clouds in the sky, had to be designed with an almost ruthless economy. Every pixel had a job to do. This is a world born of limitations, and it is in the crucible of limitation that true creativity often flourishes. Miyamoto's team couldn't create vast photorealistic monsters. They didn't have the memory for complex animations or sophisticated artificial intelligence. The enemies in this nascent mushroom kingdom had to be simple, readable, and instantly understandable. They had to be more like forces of nature than thinking creatures. A walking mushroom, a turtle that retreats into its shell. These were ideas that could be conveyed with just a handful of pixels and a simple, repeatable pattern of movement. They were visual shorthand for danger, and then there was the problem of the pipes. These green conduits were the plumbing of the kingdom, a way to travel between worlds, a defining feature of the landscape. But a pipe is also a hiding place, an ambush point. What kind of simple, elegant danger could live inside a pipe? It couldn't be too complex. It had to appear and disappear with a predictable rhythm, teaching the player not to fight, but to wait, to observe a pattern. It needed to be little more than a mouth, a simple, upward-facing, toothed threat. And so the Piranha Plant was born. A splash of red, a touch of white for teeth and spots, a stem of green. It's a masterpiece of minimalist design. It doesn't chase you. It doesn't have a strategy. It is in essence a piece of biological punctuation. It's a living stop sign. It rises, it falls, it rises, it falls. Its threat is absolute, but its timing is knowable. It is a lesson in patience, delivered in a few dozen pixels. To a child playing the game, it's just a pipe monster. But to a designer, it is a perfect solution to a complex problem. A simple, memorable form, born from the severe constraints of its digital environment. A predator perfectly adapted to its world of 8-bit logic. Now, let us leave that quiet office in Kyoto. Let the hum of the electronics fade away, and in its place, let a new sound rise. The sound of insects, a chorus of buzzing and clicking. Let the cool, conditioned air be replaced by a thick, warm humidity that clings to your skin. We are traveling back, not just in space, but deep into time. To the year 1763, we are standing on the edge of a wetland in coastal North Carolina. The world around us is overwhelmingly green and alive. Cypress trees, their bases swollen and knobby, rise from the dark, tannin-stained water. Spanish moss hangs from the branches like the grey beards of old men. The ground beneath our feet is a spongy carpet of sphagnum moss, and the air smells of damp earth, of peat, of decay and rebirth all at once. This is a subtropical bog, a longleaf pine savanna. It is an environment of profound and ancient beauty. It is also an environment of profound scarcity. The soil here, for all its lush appearance, is incredibly poor. It's acidic and sandy, leached of the vital nutrients, especially nitrogen and phosphorus, that most plants need to build their very bodies. To be a plant here is to live in a house with a perpetually empty pantry. Evolution, that brilliant but patient engineer, has had to come up with some very unusual solutions for survival in a place like this. And it is here, in this nutrient-starved landscape, that the royal governor of North Carolina, a man named Arthur Dobbs, is about to encounter something that will send ripples of astonishment across the Atlantic and into the heart of the scientific establishment. He is an amateur botanist, a man of his time, endlessly curious about the new world's natural wonders. But what he finds here, nestled in the damp moss, is something that seems to violate the very laws of nature as he understands them. He sees a small, low-lying plant, a rosette of bright green leaves spreading out from a central point close to the damp ground. But it's the end of each leaf that catches his eye. Each leaf is hinged in the middle, like a book, or a clamshell, or a tiny jaw, and the edges of these lobes are lined with what look like green eyelashes, or teeth. It is a plant that seems to be made of mouths. Dobbs, in a letter he would write back to England, described it with a sense of breathless wonder. He called it a tapiti witchet, or a flytrap sensitive. He watched, mesmerized, as an unlucky insect would land on one of these open lobes. And then, in a movement that was impossibly fast for the plant world, a world he knew as one of slow, imperceptible growth, the two lobes would snap shut, the green teeth interlocking like a cage, trapping the struggling creature inside. To say this was unusual is a profound understatement. This was heresy. In the 18th century European understanding of the world, God had created a clear and sensible order: the animal kingdom, the plant kingdom, and the mineral kingdom. Animals moved and ate. Plants were passive, silent, and drew their sustenance from the soil and the sun. They did not hunt. They did not set traps. They did not eat meat. Governor Dobbs's account, and the pressed specimens that eventually followed it across the ocean, were met with a mixture of disbelief and utter fascination. The prominent English naturalist, John Ellis, who received one of Dobbs's specimens, was the one to give the plant its official scientific name. He called it Dionea muscipula. Dionea is a reference to Dione, the mother of the Greek goddess of love, Venus, a nod to the plant's strange beauty. But muscipula is Latin. It means mousetrap. So in essence, he named it Venus's mousetrap. The name itself is a beautiful contradiction, combining the divine feminine with a crude mechanical predator. It perfectly captures the unsettling wonder the plant inspired. The debate raged in the hallowed halls of European science. How did it work? Did it truly digest its prey, or simply trap it by accident? Many botanists, unwilling to accept the reality of a carnivorous plant, insisted that the struggling of the insect must stimulate the plant to release some kind of fluid by accident, and that the plant drew no real nutrition from its captive. The idea of a plant deliberately luring, trapping, and consuming an animal was simply too monstrous, too much of a violation of the natural order. It was a botanical monster from a strange new land. And for nearly a century, this remarkable plant remained a beautiful but poorly understood curiosity. A marvel, yes, but one whose true nature was still shrouded in speculation. It would take another man, one of the greatest scientific minds in history, to truly look at this plant and begin to understand the depths of its sophistication. His name was Charles Darwin. Decades after his voyage on the Beagle, Darwin had settled into a life of relentless curiosity at his home in the English countryside. He became obsessed with climbing plants, with orchids, with earthworms, and, most passionately, with carnivorous plants. When he finally turned his full formidable attention to Dionea muscipula, he was not just interested, he was captivated, he was enthralled. He filled his greenhouse with them. He wrote to botanists in America, begging for live specimens, and he began to experiment with a patience and a meticulousness that is humbling to even consider. He treated the plant not as a passive object, but as a responsive living subject. He was less a botanist and more a detective, carefully interrogating a silent witness. He learned that the trap would not spring from the touch of a raindrop or a piece of wind-blown debris. He gently tickled the lobes with a hair and discovered the secret of the trigger hairs. These tiny bristle-like filaments on the inner surface of the lobes were the plant's security system, and it was a system of remarkable intelligence. One touch did nothing. The plant, it seemed, was waiting. It was ignoring false alarms, but a second touch within about 20 seconds of the first would trigger the trap to spring shut. This two-step verification is an incredible feat of biological engineering. It's a simple form of memory. The plant remembers the first touch for a brief period, waiting for confirmation. It's an energy-saving mechanism of profound elegance. Closing the trap requires a huge burst of energy for the plant, so it has evolved to ensure it isn't wasting that energy on a false alarm. It will only snap shut if the stimulus behaves like a living, moving insect. Darwin's experiments became more and more elaborate. He fed his flytraps tiny pieces of raw meat, drops of milk, bits of boiled egg, even a sliver of his own fingernail, and he watched. He saw how the trap would seal itself tight after capturing real food, forming what he called a temporary stomach. He observed how digestive enzymes, startlingly similar to those in our own stomachs, would be secreted to slowly dissolve the soft parts of the insect. He placed a tiny piece of glass in a trap and saw that the plant, recognizing it as inedible, would reopen a day or so later, having wasted no digestive fluids. He was witnessing in slow motion the act of hunting and digestion in a creature that had no muscles, no nerves, no brain as we would understand them. He was watching a plant behave like an animal. After all his years of study, after all his world-changing discoveries about the origins of species, this tiny plant from the Carolina bogs could still fill him with a sense of profound wonder. He concluded his work on carnivorous plants by writing that the Venus flytrap is one of the most wonderful plants in the world. And so we have our two protagonists, born into two starkly different worlds. One, a phantom of light on a screen, conceived in a quiet room in Kyoto, a creature of pure function, its form dictated by the harsh logic of limited memory and processing power. Its purpose, to be a simple, rhythmic obstacle in a digital playground. The other, a creature of flesh and cellulose, born from the pressures of a real-world environment. Its form dictated by the harsh logic of nutrient-poor soil and the evolutionary arms race between predator and prey. Its purpose, to supplement its diet, to survive, to thrive where others would starve. One is a pixelated predator. The other, a Carolina curiosity. One, a brilliant piece of human design. The other, a breathtaking product of natural selection. And yet, they share a form. A simple, upward-facing mouth, waiting in a stationary spot, ready to snap shut. It is a stunning example of convergent evolution. In a way, not of two species arriving at the same biological solution, but of a human mind, constrained by its own set of rules, independently designing a form that nature itself had already perfected, half a world and a million lifetimes away. The journey of how these two came to be is a story of ingenuity, both human and natural, and it is a story that is only just beginning. Chapter 2. The Tyranny of the Bog, Anatomy of a Botanical Hunter. And so our story begins. Not in a pixelated kingdom or on a programmer's screen, but in a very real place, a place that feels ancient, primordial, a place where the air is thick with the scent of pine needles and damp earth, and the ground itself is a paradox, a soft waterlogged carpet that offers almost nothing of what a plant needs to live. To understand this tiny gaping marvel, we must first travel to its one and only home on this entire planet. We must go to the longleaf pine savannas of the Carolinas in the southeastern United States. Here, within a sliver of land, a radius of less than 100 miles, lies the entire native kingdom of Dionea muscipula, the Venus flytrap. Settle in now. Let your shoulders soften. Let the world outside this story fade away. We are kneeling, you and I, at the edge of a moccasin, a specific type of bog. The word comes from the Algonquin, meaning swamp on a hill. The ground beneath our hands is spongy, a thick mat of sphagnum moss and peat. The sunlight filters down through the tall, sparse pines, dappling the ground in shifting patterns of light and shadow. The air is warm, heavy with humidity. You can hear the low, persistent hum of insects, a constant chorus of life that fills the space between the trees. It feels lush, vibrant, teeming with green. But this verdant world is built upon a foundation of scarcity. This is the tyranny of the bog. The soil here is acidic and waterlogged. Centuries of decaying plant matter have created a peat that is rich in carbon, but desperately poor in the two most vital nutrients a plant needs to build its proteins and its DNA, nitrogen and phosphorus. The constant moisture leaches these essential elements away, washing them out of reach of ordinary roots. For most plants, to set seed here is to be born into a famine. They would grow stunted, yellowed, and weak, unable to construct the basic building blocks of life. It's like trying to build a city with no steel and no concrete. It is a place of profound and beautiful starvation. And it is this very starvation, this tyranny, that serves as the crucible of evolution. In this quiet, nutrient-starved corner of the world, life did not give up. It became ingenious. It became radical. If the building blocks for life could not be drawn up from the soil, then they would have to be found somewhere else. They would have to be taken from the air. Not from the air itself, but from the creatures that fly and crawl through it. And so, here in the bog, we find an entire community of plants that have turned the tables on the animal kingdom. We find the pitcher plants, with their elegant, water-filled tubes that lure insects to a watery grave. We find the sundews, tiny jewels glistening with sticky, deceptive droplets of mucilage. And here, hugging the damp ground, almost invisible until you know what to look for, we find our subject. A small, unassuming rosette of green leaves, pressed flat against the moss. It looks like nothing more than a strange clover at first glance. But at the end of each leaf, it holds a weapon. A mouth, a living steel trap, designed by millennia of hunger. Let's lean in closer, gently now. The whole plant is no bigger than the palm of your hand. It grows in a circular cluster, a rosette, keeping its profile low to the ground. This isn't a plant that wastes energy reaching for the sun. Its energy comes from a different source. From each leaf stalk or petiole extends the trap itself. It is technically a modified leaf blade, but it looks like no other leaf you have ever seen. It is two lobes, two halves of a clamshell, joined at a central midrib. The outside of these lobes is a placid, unassuming green, capable of photosynthesis just like any respectable leaf. It's the inside that tells a different story. The inner surface is often a stunning deep crimson, a color that, in the plant world, is a billboard. It advertises a reward. To an insect, this splash of red in a sea of green and brown is an irresistible signal, suggesting the presence of nectar or a flower. And the plant does not lie. Along the scalloped rim of each lobe, just before you get to the teeth, are tiny, almost invisible glands that secrete a sweet, sugary nectar. An insect, perhaps a curious ant or a wandering spider, crawls onto the leaf. It tastes the nectar, a free meal. It seems too good to be true, and so it moves further in, following the promise of more sweetness towards the center of the lobes. And it is here, on that treacherous red landscape, that it brushes against the plant's nervous system. There, standing up from the red surface, are the trigger hairs. They are called trichomes. There are usually 3 on the inner surface of each lobe, arranged in a tiny triangle. They are delicate, slender, and exquisitely sensitive. They are not sensors of pressure. Not exactly. They are not waiting to be crushed. They are levers. They are designed to be bent. They are the tripwire of a finely calibrated biological machine. This is where the plant's quiet, green patience gives way to a shocking swiftness, a speed that seems to violate the very nature of being a plant. But it is not a simple mechanism. It is not a hair trigger. The Venus Flytrap is far, far more intelligent than that. A single raindrop could fall into the trap. A piece of wind-blown debris could land on a trigger hair. To snap shut on these false alarms would be a catastrophic waste of energy. A trap can only close and reopen a handful of times in its life before the leaf withers and dies. So the plant must be sure. It has evolved a system of memory, a way to count. It has evolved a form of two-factor authentication. Imagine the ant, crawling across the crimson surface. It bumps into one of the trigger hairs, bending it slightly, and in that instant, something incredible happens. Something that for centuries we believed was exclusive to the animal kingdom. A tiny electrical charge is generated at the base of the hair, an action potential. It is a genuine nerve impulse, a wave of electrical energy that sweeps across the surface of the leaf, just like a signal firing along a neuron in your own brain. But nothing happens. The trap remains perfectly still. The plant has registered the touch. It has taken note. A silent internal clock has started. A capacitor is being charged. The plant now waits, holding that electrical charge in reserve. It remembers. If nothing else happens within about 20 to 30 seconds, the charge dissipates. The memory fades. The event is dismissed as a false alarm. A raindrop, a gust of wind. But our ant continues its journey, and within that time window it inevitably bumps into a second trigger hair, or perhaps the same one again. The lever is bent a second time. A second action potential fires, and this second electrical signal, arriving while the memory of the first is still fresh, pushes the system over a critical threshold. The trap has received its two-step verification. It is no longer a question of if, but now. What happens next is a masterpiece of hydraulic engineering. It is one of the fastest movements in the entire plant kingdom, a motion that takes less than 1/10 of a second. The lobes don't have muscles, they don't have sinew or tendons, they have only the power of water and a brilliant built-in physical design. For a long time, the mechanism was a mystery. We now understand it to be a process of rapid, irreversible cell growth, a change in turgor pressure so swift it becomes a biological catapult. At the moment the second signal is received, the plant initiates what is called acid growth. It begins pumping hydrogen ions into the cell walls on the outer surface of the leaf lobes. This sudden increase in acidity loosens the cell walls, making them instantly more flexible and elastic. At the same time, water is rapidly driven from the cells on the inside of the leaf to these newly pliable cells on the outside. The outer cells swell almost instantly. The inner cells shrink. This dramatic instantaneous difference in pressure across the midrib causes the entire leaf structure to change its geometry. The trap, in its open state, is held in a convex shape, like a bowl turned upside down. It's a state of stored tension, bistable, like a soft plastic popper toy you might push inside out. The sudden swelling of the outer cells releases this tension, causing the leaf to snap from its convex shape to a concave one like a bowl turned right side up. It's not a closing, so much as an inversion, a catastrophic, beautiful collapse. The snap is lightning fast. The scalloped edges of the lobes, fringed with those long eyelash-like spines called cilia, slam shut. But they don't seal completely, not at first. The cilia interlace like the fingers of two clasped hands, forming the bars of a cage. This is another stroke of evolutionary genius. If the trapped insect is too small, it can easily crawl out between the bars. The plant has decided that such a small meal isn't worth the energy of a full digestion. It is a built-in escape hatch for the unworthy. The trap will then slowly reopen over the next several hours, resetting itself, having wasted a bare minimum of energy. But our ant is large enough. It is caught. Panicked, it struggles against the bars of its green prison, and its struggle is its doom. Every frantic movement, every touch against the inner surface of the trap, stimulates those trigger hairs again and again. A third touch, a fourth, a fifth. These subsequent signals tell the plant something new, not just that there is prey, but that it is viable, struggling prey. This is the final confirmation. This is the signal to begin the second phase. Slowly, over the next hour, the trap begins to tighten. The lobes press together, the cilia fold inward, and the edges of the leaf form a perfect hermetic seal. The trap is no longer a cage, it has become a stomach. The air is squeezed out, and the chamber becomes watertight. Now, and only now, does the plant commit its most precious resource. Glands on the inner surface of the leaf, the same crimson surface that served as a lure, begin to secrete a cocktail of digestive enzymes. It is a slow, methodical process of external digestion. The fluid fills the small chamber, bathing the trapped insect. There are proteases to break down proteins, chitinases to attack the exoskeleton, nucleases to dissolve DNA. It is a potent acidic brew, not so different from the fluids in our own stomachs. For the next 5 to 12 days, the plant will simply wait. Patiently, silently, it dissolves the soft tissues of its prey, breaking down the complex molecules of the insect's body into their simple, elemental components. It is not after calories for energy. It gets plenty of that from the sun, through photosynthesis. It is after the building blocks. It is harvesting the nitrogen and phosphorus that its roots could never find in the poor acidic soil of the bog. It is absorbing the very atoms it needs to build new leaves, new traps, new trigger hairs. It is drinking its victim. When the process is complete, when all the nutrients have been absorbed through the surface of the leaf, the glands stop secreting and begin to reabsorb the digestive fluid. The work is done. Then, with a slowness that is a stark contrast to its violent closing, the trap begins to reopen. Over a day or more, the lobes pull apart, unsealing their grim chamber. What is left inside is a dry, empty husk. The indigestible exoskeleton of the ant, a perfect hollow shell, all of its life-giving elements stripped away. The rain and the wind will eventually wash this tiny skeleton away, cleaning the trap. It is now reset, ready for its next meal. But it can only perform this incredible feat 2 or 3, maybe 4 times. Each cycle of closing, digestion, and reopening takes a tremendous toll. After its last meal, the leaf and its trap will turn black, wither, and die, its hard-won nutrients recycled back into the main plant to fuel the growth of a fresh new hunter. And as we watch this cycle, a fundamental question arises, a profound biological dilemma. This plant has perfected a method for capturing and killing insects, but like most flowering plants, it relies on insects for pollination. It needs them to carry pollen from one flower to another to create seeds and reproduce. So how does it solve this problem? How does a Venus flytrap avoid eating its friends? How does it separate its pollinators from its prey? The answer is another example of nature's simple architectural elegance. Look up from the rosette of traps on the ground. In the late spring and early summer, the plant sends up a flower stalk. But this stalk doesn't just grow a few inches. It grows tall, straight, and slender, reaching far, far above the deadly mouths below. At the very top, a foot or more in the air, a cluster of delicate white flowers opens to the sun. It is a solution of spatial separation. The dining room is on the ground floor, the bedroom is in the penthouse. The traps are perfectly positioned to capture crawling insects, spiders, ants, beetles that move along the surface of the bog. The flowers, meanwhile, are held high in the air, presented to an entirely different clientele, flying insects like bees and hoverflies. These pollinators move from flower to flower, high in the breezy, open air, likely completely unaware of the deadly drama unfolding on the ground beneath them. The plant has engineered its own body to occupy 2 separate ecological niches at once. It is a masterful division of labor, ensuring that its vital partners are never, ever on the menu. This clever separation allows the cycle of life to continue. After pollination, the white petals fall away, and the flowers develop into seed pods. Each pod contains dozens of tiny, teardrop-shaped seeds, as black and shiny as obsidian. When the pod dries and cracks open, these seeds are scattered onto the surrounding moss. For a seed to germinate and grow into a mature hunting flytrap is a long and arduous journey, taking several years. But the plant has another strategy for survival, one hidden beneath the soil. It grows from a rhizome, a thick, fleshy underground stem that acts as a storage organ. It is a bulb-like structure that holds the energy reserves of the plant. This rhizome is the key to its resilience. The bog ecosystem is not just defined by its poor soil, but also by fire. Historically, natural wildfires would sweep through the pine savannas, clearing out underbrush and competing shrubs. A fire would burn away the flytrap's leaves and traps, but the rhizome, insulated by the damp soil, would survive. In the aftermath of a fire, with the sunlight reaching the ground and competition cleared away, the flytrap would send up new leaves from its rhizome, thriving in the newly opened landscape. It is a plant that is not just adapted to scarcity, but also to catastrophe. So when we look at this plant, we are not looking at a mere botanical curiosity. We are not looking at a monster or an anomaly. We are looking at a specialist of the highest order. It is a creature born of intense evolutionary pressure, a living portrait of a very specific place. Its every feature, its trapping mechanism, its electrical memory, its digestive chemistry, its physical architecture, is a direct answer to the question posed by the tyranny of the bog. How do you live where there is nothing to live on? The Venus flytrap's answer is to become a hunter, to develop a system so sophisticated it borders on the neurological, to create a leaf that is also a sensor, a calculator, a hydraulic press, and a stomach. It is a profound reminder that life is relentless in its creativity. It fills every crack, solves every puzzle, and in the most inhospitable of places, it often produces the most bizarre and beautiful solutions. Its existence is a delicate one, however. Its entire world, its entire kingdom, is that small patch of Carolina wetland, and that world is shrinking. The draining of bogs for agriculture and development, the suppression of natural fire cycles, and the sad reality of poaching for the horticultural trade have pushed this incredible species to the brink. It is now considered vulnerable, its small empire threatened by the expansion of our own. To kneel in the damp moss and watch a trap snap shut on an unsuspecting fly is to witness a piece of evolutionary magic, a process honed over millions of years. It is a silent, breathtaking drama that plays out 1,000 times a day in a world most of us will never see. It is a humbling perspective check. It reminds us that ingenuity is not solely a human trait, that memory, calculation, and swift, decisive action are not the exclusive domain of creatures with brains and nerves. Nature, in its quiet, patient, and sometimes ruthless way, has already engineered wonders that we are only just beginning to truly understand. It's a testament to the idea that on this planet, life has explored almost every possibility, and the line between the world of plants and the world of animals is far more blurry and far more wondrous than we could ever have imagined. Chapter 3. From Pipe Dweller to Playable Character, a Digital Metamorphosis. And yet, this blurring of the lines, this quiet and wondrous confusion between the kingdoms of life, is so utterly compelling, isn't it? It's so deeply fascinating that it's no wonder our own human imagination has seized upon it, time and time again. We see these marvels in the real world, a leaf that snaps shut, a flower that mimics an insect, a fungus that communicates through a forest-wide web, and we cannot help but reflect them in our stories, in our art, and in the digital worlds we build. We create echoes of nature's ingenuity, and perhaps one of the most famous, most enduring of these digital echoes began its life in 1985. It was a simple creature, born of severe limitations, a being crafted from a tiny handful of colored squares. It lived of its own accord in a world of perfect flat geometry. Its home was a simple green pipe, emerging from the ground or a ceiling of ordered bricks. It was, of course, the Piranha Plant. And tonight, let us trace the remarkable evolutionary journey of this idea, this digital organism, as it adapted and thrived in the ever-changing ecosystem of its virtual world. Think back to that first encounter. The world of the Mushroom Kingdom was a revelation, a place of vibrant color and startling life. But it was a world governed by simple, reliable rules. Goombas walked in straight lines, Koopa Troopers marched with a predictable cadence, and from the mouth of a pipe, a new form of life would emerge, not to pursue, but to wait. It was the absolute distillation of the Venus Flytrap's core strategy, the sit-and-wait predator. This first Piranha Plant was a creature of pure rhythm. It rose, it paused with its spotted head held high, its simple-toothed maw open, and then it retreated back into the safety of its pipe, up and down, a living metronome of danger. Its existence was a simple binary loop. If the hero Mario was standing right beside its pipe, it would remain hidden, a silent acknowledgement of immediate overwhelming threat. It had a primal rudimentary awareness. It knew when to hide, but step away, give it just enough space, and the cycle would resume, a patient botanical trap resetting itself. In the world of 8-bit design, every single pixel was a precious resource. There was no room for biological nuance. The designers couldn't render the intricate trigger hairs of a fly trap or the slow, deliberate secretion of digestive enzymes. They had to capture the essence, and they did so brilliantly. The white-spotted red head communicates a warning, a pattern seen throughout nature in things like the Amanita muscaria mushroom, a universal signal for do not touch. The jagged white line of its mouth is a perfect economical representation of teeth, instantly conveying its carnivorous nature. And its home, the pipe, is its anchor, its soil, its entire world. It is a creature utterly defined by its location, just as a real carnivorous plant is defined by the patch of nutrient-poor soil it has adapted to dominate. This simple looping behavior, this digital instinct, is not so different from the mechanical reality of the Dionea muscipula. The fly trap doesn't think. It doesn't see the fly coming. Its trap is governed by a simple, elegant system. A touch on a trigger hair primes the mechanism, a hydraulic change in its cells, A second touch within about 20 seconds provides the confirmation, and the trap snaps shut. It is a biological machine, performing a function. The first Piranha Plant is its digital counterpart, a simple machine made of code, executing a loop. Wait for the player to move, rise from the pipe, wait for a set time, descend. The genius of it was in how this simple, predictable pattern created a compelling challenge. It wasn't an enemy to be fought, so much as a rhythm to be learned, a puzzle of timing woven into the very fabric of the world. You had to understand its pulse, its cadence, to move past it. You had to learn the dance of this simple digital predator. It was the common ancestor, the simple, successful body plan from which all future complexity would spring. And spring it did. As the digital ecosystem it inhabited grew more complex, so too did the Piranha Plant. The world of Super Mario Bros. 3 was a grand expansion, a burst of creative energy that felt like a Cambrian explosion. The simple rules of the old world were being rewritten, and with this came the first great speciation event for our pipe-dwelling friend. The original design, the simple up-and-down rhythm, was still present. It was a successful strategy after all, and nature rarely abandons what works. But now, it shared its world with new, more specialized cousins. Suddenly, some piranha plants could do more than just wait. They could project their threat outwards. They could spit fire. Think of this adaptation. For the player, for the little plumber navigating this world, the zone of danger was no longer just the space immediately above the pipe. It was a projected line, a fiery missile that demanded a new level of awareness and a new kind of aerial agility. In biological terms, this was a monumental leap. A stationary predator had developed a ranged attack. It is the digital equivalent of a plant evolving a chemical defense that can be sprayed, or like the archerfish, which remains in one place but can precisely spit a jet of water to knock an insect off a leaf and into its grasp. The piranha plant was no longer just a localized hazard. It was becoming an active participant in the contest for survival. But another variation emerged in that world that was, perhaps, even more profound in its implications. This was a variety of piranha plant, known as the tui. It didn't spit fire, but instead it levitated a spiked metal ball on a column of its own breath. It would gently blow this ball upwards, hold it, and then let it fall, before repeating the cycle. Sometimes it would even walk back and forth, patrolling a small area, all while juggling its weapon. Let's pause and appreciate the significance of this. This is a digital organism exhibiting tool use. It is manipulating an external object to create a defensive or offensive perimeter. The simple binary loop of its ancestor has evolved into a far more complex behavior. It requires a different kind of timing, a different understanding of physics from the player. You can't just wait for it to descend into its pipe. Its threat is persistent, a constant floating barrier. This evolutionary leap, from a simple trap to a creature that actively wields a weapon, represents a staggering increase in complexity. It suggests a new level of interaction with its environment. It was a sign that the digital DNA of this creature was incredibly versatile, capable of being twisted and reshaped by the selective pressures of game design into ever more fascinating forms. And then, the world changed. It didn't just expand, it deepened. The flat two-dimensional plane of existence gave way to a universe with 3 dimensions. The arrival of Super Mario 64 was a cataclysmic event for the digital life forms of the Mushroom Kingdom. It was like the moment life first crawled from the sea onto the land. The very laws of physics and movement were fundamentally rewritten. An organism that had evolved for a 2D world, for a life of moving up and down or left and right, was now faced with a world that had a Z-axis. A world with depth and perspective and true freedom of movement. How does a creature like the piranha plant, a being defined by its stationary rhythmic existence, survive in such a world? This was the great challenge for the designers, the forces of evolution in this digital space, and their solution was a brilliant example of adaptive radiation. The piranha plant didn't just adapt, it diversified to fill new ecological niches that this third dimension provided. Some remained true to their ancestral form, living in patches of soil, emerging to bite. But they were no longer simple 2D sprites. They were fully realized, 3-dimensional beings. You could run circles around them. Their threat was no longer a vertical line, but a sphere of influence around their snapping jaws. They would track you, turning their heads to follow your movement, a new, more active form of awareness. But more startling was the emergence of entirely new forms. Tiny seedling-like piranha plants would sprout from the ground, not to wait, but to actively nip at Mario's heels. They were small, almost an annoyance, but they represented a fundamental shift. They were no longer anchored. They were free-roaming. They had, in a sense, evolved from a sessile, plant-like existence into something more mobile, more animal-like. This was that blurry line between kingdoms, being explored in real time. And then there were the giants, sleeping giants. In the level Womp's fortress, you would come across a serene grassy field, and sleeping in that field were massive piranha plants, their huge spotted heads lolling to the side, gentle snores emanating from them as digital Z's floated into the air. The challenge here was not one of combat, but of stealth. You had to move with the gentleness of a field mouse, tiptoeing past the sleeping predator. If you ran, if your footsteps were too heavy, they would awaken with a startling roar, their huge jaws snapping ferociously. This was a piranha plant, designed not to test your reflexes, but your patience. It was a behavioral evolution. The creature now had states of being, sleeping and awake. It responded not just to proximity, but to the sound and speed of the player's movement. Its sensory apparatus, though entirely virtual, had become far more sophisticated. It was a predator you had to outwit, not just outrun. It was a testament to how the new 3D environment allowed for richer, more nuanced forms of life to emerge. As the technology of this digital universe continued to advance, the adaptive radiation of the piranha plant became even more pronounced. The designers, like a patient and endlessly creative Mother Nature, took the basic blueprint, the toothed, spotted floral carnivore, and applied it to every conceivable environment. In the zero-gravity worlds of Super Mario Galaxy, we saw naval piranhas, aquatic variants that would shoot toxic sludge, their bodies adapted for a life suspended in cosmic water spheres. We saw stalking piranha plants in later games, their heads attached to long, thorny vines that would snake along the ground, actively hunting the player, a terrifying fusion of the stationary trap and the mobile hunter. And this evolutionary path led, as it so often does in the real world, to gigantism, to the emergence of an apex predator. His name was P.T. Piranha. He wasn't just a bigger piranha plant. He was a character, a boss, a being with a personality, conveyed entirely through his animations and his attacks. With his leaf-like arms, his stubby root legs, and his enormous expressive mouth, P.T. was the T-Rex to the original piranha plant's tiny Compsognathus. He had complex attack patterns that had to be learned and countered. He had specific weaknesses that had to be exploited. He would fly, he would charge, he would spit goo. He was a multi-stage ecological disaster in the form of a single organism. The battles with P.T. Piranha were a conversation. They were a dialogue of action and reaction that was worlds away from the simple rhythmic dance of his 8-bit ancestor. He represented the piranha plant concept reaching a new level of sentience within its world. He was no longer just a part of the environment. He was a force of nature in his own right, a true antagonist with a presence and a sense of self. This trend from simple obstacle to complex character was a slow, gradual process, happening over decades of digital evolution. But it was all leading to one final, unbelievable transformation. The ultimate apotheosis, the final and most profound evolutionary leap. It happened in the world of Super Smash Bros. Ultimate. This is a world where the greatest icons of gaming history come together to compete. It is a pantheon of heroes, villains, and legends, and into this pantheon, a new challenger was announced. It was not a hero with a sword, or a princess with magic, or a soldier with a gun. It was a plant, the piranha plant. The reaction from the community was, at first, one of sheer comical disbelief. A piranha plant, a common garden variety enemy. How could this simple creature possibly compete with the likes of gods and super soldiers? But then we saw it in action, and we understood. This was not just a piranha plant. This was the culmination of its entire evolutionary history, a living embodiment of its long and storied lineage. Its transformation from a piece of environmental design into a fully realized playable character is one of the most remarkable stories in this digital ecosystem. To do this, the designers had to give it something its ancestors never had: agency, a will of its own, directed by a human player. They had to construct a brain for it, in the form of a complex, balanced and creative moveset. And to do so, they reached back through its entire fossil record. Its basic attack, of course, is the bite, the quintessential move of its common ancestor from 1985. Simple, effective, iconic. But then you see its other abilities. It can spit a spiked ball and juggle it on a puff of air, a direct homage to the Tui from Super Mario Bros. That first instance of tool use. It can stretch its neck out to incredible lengths, a nod to the stalking piranha plants of more modern games. It can duck down into its pot, which it now carries with it like a snail carries its shell, a perfect defensive maneuver that calls back to its ancestral instinct to hide in its pipe. It can even summon its gargantuan form, PT Piranha, for its ultimate attack, a final devastating flurry of bites from a cage of giant plant heads. Every single move is a piece of its history. Its moveset is a living museum exhibit, a celebration of its digital DNA. Playing as the Piranha Plant is like taking control of evolution itself. You are wielding every adaptation, every strange and wonderful mutation that it has acquired over more than 30 years of survival. And in giving it this agency, this complex suite of behaviors that a player can choose from in a split second, the designers effectively gave it a mind. The Piranha Plant in Super Smash Bros. Can now do what its real-world inspiration, the Venus Flytrap, cannot. It can strategize. It can predict. It can set traps with its poison breath, control space with its spiked ball, and punish mistakes with its ferocious bite. It can learn, adapt, and overcome. It has completed the journey. It has crossed that blurry line for good. It began its life as a simple, unthinking piece of flora, a digital plant, and it has become, for all intents and purposes, a member of the kingdom, Animalia, a thinking, fighting creature with a soul. The journey from a rhythmic 8-bit obstacle to a beloved top-tier fighting character is a testament to the power of a simple, elegant idea rooted in the real world. The Venus Flytrap, in all its quiet mechanical brilliance, provided a spark of inspiration so potent that its digital echo has been evolving for decades. It has survived hardware changes, dimension shifts, and genre jumps. It has diversified into countless forms, each one a clever solution to a new environmental pressure. It is a beautiful parallel to evolution in our own world. A simple, successful body plan can give rise to an astonishing array of descendants. A creature that starts as a humble bottom-dwelling filter feeder can eventually give rise to lineages that walk and run and climb and fly and even think. The Piranha Plant story is a compressed digital version of that grand narrative. It's a reminder that even the simplest forms of life, real or virtual, contain within them the potential for incredible complexity and unimagined futures. It began as a simple trap, a thing to be avoided, and it ended up a champion, a character to be celebrated, its strange, toothy grin cemented forever as an icon, not of a simple obstacle but of the strange and wonderful journey of life itself. Chapter 4. The Green Maw, a cultural history of man-eating plants. And even think. The Piranha Plant story is a compressed, digital version of that grand narrative. It's a reminder that even the simplest forms of life, real or virtual, contain within them the potential for incredible complexity and unimagined futures. It began as a simple trap, a thing to be avoided, and it ended up a champion, a character to be celebrated, its strange, toothy grin cemented forever as an icon, not of a simple obstacle, but of the strange and wonderful journey of life itself. But what journey is that, really? Where does an icon like this come from? A toothy, hungry plant rising from a green pipe. It feels so familiar, so instantly understood even to a child. We know without being told that this is a thing of mild peril. We know to be wary of its bite. But why? Why does this particular image, a carnivorous plant, hold such a deep and immediate power in our collective imagination? To understand the Piranha Plant, we have to look past the pixels and the cheerful 8-bit music. We have to trace its roots back, not through the history of video games, but through the much deeper, darker soil of human fear. The story of the Piranha Plant is the final, friendliest chapter in a long and often terrifying history, the history of the man-eating plant. It all begins with a fundamental violation of the rules. Think about the world as we first understand it. The ground beneath our feet is solid, dependable. The sky is up, the earth is down, and the great kingdoms of life have their roles. Animals move, and hunt, and eat. Plants, for the most part, stay still. They are the scenery. They are the backdrop to the drama of the animal world. They are food. It is an order we rely on, a truth that feels as ancient and stable as the mountains. The carnivorous plant, even our tiny real-world Venus Flytrap, whispers a deeply unsettling thought. What if that order is wrong? What if the scenery can fight back? The flytrap itself, of course, is no threat to us. It is a miracle of miniature engineering, a marvel of evolutionary adaptation, but it is small. Its traps, those green eyelash-fringed jaws, are barely large enough to hold a housefly. It is a hunter of the minuscule, but in its existence it provides a crucial, terrifying proof of concept. It proves that a plant can set a trap. It proves a plant can have a mouth. It proves a plant can kill and digest and feed on flesh. And once that seed of possibility is planted in the human mind, our imagination is a very fertile place for it to grow. And grow it did, into something monstrous. Let's travel back for a moment to the late 19th century, a time of breathtaking discovery and profound anxiety. European empires were stretching their fingers across the globe into jungles and continents that had for millennia been mysteries. Explorers were returning with sketches and specimens of creatures that defied belief. Birds of paradise with impossible plumage, insects that mimicked leaves with perfect precision, orchids of unearthly beauty. The world was suddenly thrillingly full of things that were stranger than fiction. In this atmosphere of genuine wonder, it was easy to believe that anything was possible. If nature could produce a giraffe, a platypus, or a pitcher plant that drowned rats, then what couldn't it do? The line between the real and the fantastic was blurry, and the public had a ravenous appetite for the strange. And so, in 1874, the readers of the New York World newspaper were treated to a story that would curdle their blood. It was a dispatch, supposedly written by a German explorer named Karl Licher, detailing a horrific discovery deep in the jungles of Madagascar. He wrote of a local tribe, the Makodo, and a religious ceremony that centered around a terrifying tree. He called it the Krynos, the devil tree. Let's just pause and picture the scene he painted. Imagine standing at the edge of a clearing, the air thick with humidity and the drone of unseen insects. In the center stands not a normal tree, but something grotesque. A trunk like a bloated pineapple, dark and mottled, rising 8 feet from the ground. From its top, not branches, but long hairy green tendrils that hang limply to the ground, like the arms of a monstrous squid. And above those, a crown of huge stiff leaves, forming a sort of broad plate. The story described a ritual. The tribe, chanting and swaying, forces a young woman to the base of the tree. She is made to drink a strange sap from a gourd, and then, in a kind of narcotic trance, she is forced to climb the trunk. As she reaches the top, standing on that plate of leaves, the tree awakens. The tendrils, suddenly alive with a hideous intelligence, rise up. They wrap around her neck, her arms, her body, pulling her down. Then the great stiff leaves of the crown slowly, inexorably begin to fold inwards, crushing her in a monstrous embrace. Lich describes hearing a terrible cracking of bones and then seeing a liquid, a mixture of blood and the tree's own viscous sap, dripping down the dark trunk. The tribe watches placidly for 10 days until the leaves unfold to reveal nothing but bleached white bones. It was a masterpiece of horror. It was vivid, detailed, and it fit perfectly with the Victorian public's perception of so-called savage lands, places of dark ritual, and a nature that was actively, malevolently hostile. The story was reprinted in newspapers around the world. It became a sensation. The man-eating tree of Madagascar was, for a time, treated as fact. Of course, it was all a lie. There was no Karl Leach, there was no Makodo tribe, and there was certainly no Krynos devil tree. It was a complete fabrication. A piece of sensationalist fiction cooked up to sell newspapers. Later investigations found no evidence of it, and the story's author was eventually revealed. But it didn't matter. The idea was too powerful. The seed had not just taken root, it had grown into a dark and mighty oak in the landscape of our fears. The story of the Madagascar tree was so successful because it wasn't just about a monster, it was a reflection of the anxieties of its time. It was a story about the perceived dangers of the unknown, the fear of the other, and the terrifying thought that humanity was not in fact the undisputed master of the natural world. In the dark places of the map, the story suggested the plants might just be waiting to eat us. This fictional tree became the archetype. It established the key ingredients of the man-eating plant trope: the grasping tendrils, the crushing maw, and the slow, horrifying process of digestion. It was a blueprint for a monster, and as the 19th century gave way to the 20th, that blueprint would be used again and again. The man-eating plant migrated from the pages of newspapers to the lurid, colourful covers of pulp magazines. Here, in the worlds of science fiction and fantasy, the trope truly blossomed. In these stories, monstrous flora was a common feature of distant planets and lost continents. Heroes with ray guns and chiseled jaws would find themselves entangled in the writhing vines of the Venusian blood blossom or fighting off the snapping jaws of the Martian spineweed. These pulp fiction plants were less about subtle psychological horror and more about action and adventure. They were often just another obstacle for the hero to overcome, like a swamp full of alligators or a den of giant spiders. But they kept the idea alive, cementing the image of the aggressive, carnivorous plant in the popular consciousness. They were the monster of the week, a reliable and effective threat. But the trope was about to evolve. It was about to become something more than just a jungle hazard. It was about to become intelligent. In 1951, the British author John Wyndham published a novel that would elevate the killer plant from a simple monster to a truly apocalyptic threat. The book was The Day of the Triffids, and here the nature of the fear changed profoundly. Wyndham's triffids are not stationary traps. They are not confined to a single clearing in Madagascar or a valley on Mars. They can move. They walk on 3 root-like legs, shuffling across the landscape. They have a long whip-like stinger that can lash out and kill a human with a single strike of potent venom. And most terrifying of all, they seem to be able to communicate. They hunt in packs. They learn. They are intelligent. The novel begins with a double catastrophe. A mysterious green meteor shower fills the sky one night, a beautiful and mesmerizing spectacle that almost everyone on Earth stays up to watch. The next morning, everyone who watched it is blind. Society collapses overnight, and into this new world of helpless, sightless humans step the triffids. These plants, originally cultivated by humanity for their valuable oils, are now the new masters of the planet. The story is a harrowing tale of survival, as the few remaining sighted people try to rebuild society while being relentlessly hunted by these walking, thinking vegetables. What makes the triffids so terrifying, and what makes Wyndham's book a masterpiece, is that they represent a complete inversion of power. It's not just a plant that eats a person, it's an entire kingdom of life rising up to replace us. The fear in The Day of the Triffids is not just the fear of being stung and eaten, it's the Cold War-era fear of societal collapse, the fear of our own fragility, and the chilling existential dread of being rendered obsolete. The triffids are nature's revenge, a silent, shuffling green tide that is reclaiming the earth from a humanity that has been humbled. They are not just monsters, they are our inheritors. This was a monumental shift. The man-eating plant was no longer just a bizarre specimen from a faraway land. It was now a potential global threat, a rival species. The trope had grown up, becoming a vessel for our deepest anxieties about our own place in the world and our fears of a future we couldn't control. And just as the trope reached its peak of apocalyptic horror, it was about to take another, very strange turn. It was about to come down from the global stage and into a dusty little flower shop on Skid Row. It was about to learn how to sing. In the 1960s, a low-budget black comedy film called The Little Shop of Horrors introduced the world to a plant named Audrey II. This film, and especially the hit musical it later inspired, would change the man-eating plant forever. Audrey II is not a mindless force of nature like the Madagascar tree, nor is it a silent, calculating hunter like the triffids. Audrey II has a personality, and what a personality it is. It's a jive-talking, rhythm and blues singing, manipulative and deeply charismatic monster. It starts as a tiny, strange-looking seedling, discovered by the nebbish floral assistant Seymour Krelborn. He names it Audrey II, after his co-worker and secret love, Audrey. At first, the plant is a curiosity, bringing fame and fortune to the struggling shop. But Seymour soon discovers its terrible secret. The plant feeds on blood. At first, it's just a few drops from Seymour's own pricked finger. But the plant grows, and as it grows, its appetite becomes more demanding. "Feed me, Seymour," it bellows, its voice a deep, soulful growl. "Feed me all night long." Audrey II is perhaps the most insidious man-eating plant of all, because it doesn't just hunt you, it makes a deal with you. It offers Seymour everything he's ever wanted: success, money, and the girl of his dreams. All it asks for in return is a little blood, and then a little more, and then a body, and then another. This is the story of a Faustian bargain. It's a parable about the corrupting nature of ambition and greed. The horror of Audrey II isn't just that it eats people, it's that it tempts us into becoming its accomplices. Seymour, a fundamentally good-hearted person, finds himself committing murder to feed his creation, all to maintain the wonderful new life the plant has given him. Audrey II represents another evolution of the trope. The monster is no longer in a remote jungle or part of a global apocalypse. It's right here, in our own community. It's a domestic horror, and it's not just an external threat, it's an internal one. It's a physical manifestation of our own darkest desires. It's the voice that whispers, "You can have it all for a price." By giving the plant a voice, a sense of humor, and a catchy soundtrack, Little Shop of Horrors made the man-eating plant both more terrifying and more entertaining than ever before. It was a monster you could tap your foot to. So now let's look at the path we've traveled. We began with a fabricated tale of a monstrous, silent tree in a distant land, born from colonial anxieties. We moved to the pulp adventures of spacefaring heroes fighting tentacled vegetation. Then we witnessed the world ending under the patient, shuffling march of the intelligent, terrifying Triffids, a reflection of our Cold War fears. And finally we found ourselves in a flower shop, listening to the soulful demands of a plant that promised us the world in exchange for our humanity. Each of these iterations, the Madagascar tree, the Triffids, Audrey II, was a landmark. Each took the core idea of a carnivorous plant and shaped it to reflect the fears and fascinations of its time. And that brings us back to that little green pipe in the Mushroom Kingdom. In 1985, Super Mario Bros. Was released, and out of that pipe popped the Piranha Plant. At first glance, it seems so much simpler than what came before. It has no complex backstory. It doesn't sing. It's not part of a global invasion. It has no personality, no voice. It just rises and falls, its mouth chomping. A simple obstacle governed by a simple pattern. But look closer. All the history is there, distilled into its purest, most essential form. Like the Madagascar tree, it is a stationary trap. It waits for you to come to it. Its danger is localized. It doesn't chase you, you must navigate around it. Its design, a stalk with a giant toothed maw on top, is a direct, albeit cartoonish, descendant of those early pulp magazine monsters. The spots, the round head, it's a design that says plant, but the teeth say danger. Like the Triffids, it is part of a larger hostile world. The Mushroom Kingdom is not a safe place. Everything from the turtles to the mushrooms themselves seems to be out to get our hero. The Piranha Plant is just one piece of a natural world that has been turned against you, a small repeating echo of the Triffids' global threat. And like Audrey II, there is a strange, almost comical element to it. It's not truly terrifying. It's a nuisance. Its chomp is accompanied by a simple sound effect, not a scream of agony. Its defeat is a simple puff of smoke. It is a monster that has been made safe for children. It is, in essence, a sanitized, family-friendly distillation of a century of horror. The genius of the Piranha Plant is its simplicity. It strips away all the complex allegories and cultural anxieties and leaves only the pure, functional core of the trope, a plant with a mouth that is dangerous. In the fast-paced world of a side-scrolling video game, you don't have time for a story about colonial fear or a critique of consumerism. You need an instantly readable symbol. You need a visual shorthand for don't touch. And the Piranha Plant is the perfect shorthand. It taps into that entire cultural history we've just explored. We see it, and our brains access a century of stories about grasping vines and snapping jaws. We know what it is and what it does without a single word of explanation. It's a piece of brilliant, efficient design that leans on the cultural foundation built by all the monstrous plants that came before it. But something remarkable happened. Because of the unprecedented global success of the Super Mario franchise, this simple, distilled version of the monster has, for billions of people, become the definitive version. If you ask a child today to draw a scary plant, they are far more likely to draw something that looks like a piranha plant than a Triffid or the tree from Madagascar. It has become the new archetype. A century of terror, of complex social commentary, of genuine horror has been filtered down, polished, and repackaged into this cheerful polka-dotted, pipe-dwelling icon. The journey from a terrifying, blood-soaked hoax to a beloved video game character is a strange one. It shows how our monsters evolve with us. They change their shape to fit our media, and they soften their edges to fit our entertainment, and all the while, somewhere in a quiet bog in North or South Carolina, a real Venus Flytrap is waiting. It is utterly unaware of the monstrous, globe-trotting, world-ending, show-tune-singing shadow it casts in our imagination. It feels the faint touch of an insect's leg, a delicate trigger. and in a flash of green, its own small toothy grin snaps shut. The real trap doesn't need a story. It doesn't need a story. It doesn't need a song. It is simply, quietly, and perfectly real. And perhaps that is the most wondrous thing of all. The stories we tell about nature, the monsters we create, often say so much more about us than they do about the world outside. They are reflections of our own fears, our own hopes, and our own strange and endless creativity. The green moor, in the end, is not out there in the jungle. It has been inside our own minds all along. Chapter 5. Chapter 5. Nature's Code, Nintendo's Sprite, Deconstructing the Inspiration. And so we find that the most potent monsters are the ones we carry within us. They are born in the quiet, fertile soil of our imagination. But sometimes what sprouts from that soil is not a creature of nightmare, but a creature of pure, playful fancy, a caricature, an echo translated from the complex language of biology into the simple, vibrant language of a video game. The green moor we imagined in the deep jungle finds a curious and much more cheerful reflection in a digital kingdom of mushrooms and turtles. It has been there all along, waiting for us in a green pipe. Let us now take these two incredible things, the real living Venus Flytrap, a masterpiece of patient evolution, and the Piranha Plant, an icon of interactive entertainment, and place them side by side. Let us gently, and with great admiration for both, trace the lines of inspiration from the natural world to the digital one. It is a fascinating journey, a story of how nature's code becomes Nintendo's Sprite. We begin with the most obvious, the most immediate connection, the image itself. Look at the Venus Flytrap. Its trap, technically a modified leaf, is formed of two lobes, a beautiful bilobed structure hinged at the center. It is an organic, elegant piece of engineering. When open, it has a gentle curve, like cupped hands. Now look at the Piranha Plant. The core shape is there, the idea of a hinged mouth, a gaping maw, but it has been simplified, stylized into something much more geometric. It is a sphere, often white with red spots, with a perfect wedge cut out for the mouth. The graceful curves of the leaf have been replaced with the clean, simple lines of a cartoon. This is the first act of translation. Reality's complexity is streamlined for visual clarity. A player, in a fraction of a second, needs to recognize this shape as a mouth, as a threat. The simple, bold geometry communicates this instantly, in a way the delicate form of the real plant might not. And then there is the color. The inside of the Venus Flytrap's trap is often a brilliant, blushing red. This deep crimson is produced by pigments called anthocyanins, the same compounds that give color to raspberries and autumn leaves. For the plant, this color serves a purpose. To an insect, this vivid red combined with the glint of nectar might mimic the appearance of a flower or perhaps even flesh. It is a lure, a billboard advertising a sweet and ultimately fatal meal. The game designers at Nintendo clearly saw this. The Piranha Plant's mouth is almost always a bold primary red, but the purpose of this color has been repurposed. In the language of video games, red is a universal symbol. It means danger. It means stop. It means weak point. It draws the player's eye and communicates hazard without a single word of text. The biological lure has become a gameplay warning. The plant is not trying to entice Mario to come closer. It is warning him to stay away. The very same color, once a subtle invitation in a quiet bog, is now a loud alarm in a bustling digital world. It's a beautiful example of how an artist can take a detail from nature and give it an entirely new meaning, simply by changing the context. And what of the teeth? This is perhaps the most striking and misunderstood feature. The edges of the Venus Flytrap's lobes are lined with long, elegant spines called cilia. When you see them, your mind immediately makes the connection to a predator's teeth, a jaw lined with sharp incisors. It's a powerful, primal image, but the truth of these cilia is far more subtle and in many ways more clever than any tooth. When the trap snaps shut on an insect, these cilia interlace, but they don't form a solid wall. They create a cage. They form the bars of a tiny prison. This design is a work of frugal genius on nature's part. It ensures that the prey which triggered the trap, a fly, a spider, a beetle of sufficient size, cannot escape. But it also means that any very small insects, those too tiny to be worth the energy of digestion, can simply crawl out between the bars. It's a filter. The plant doesn't waste its precious energy on a meal that isn't worth the effort. It's not chewing, it's selectively imprisoning. Now, let us turn to the piranha plant. Its mouth is lined with sharp, triangular, and brilliantly white teeth. There is no subtlety here. These are not prison bars. They are daggers. They are the classic cartoon representation of a predator's bite. They exist for one reason alone, to visually communicate the idea of biting, of damage, of danger. They don't need a biological function, because their function is purely symbolic. They are borrowing from our shared visual library of what makes a monster monstrous. While the real plant's cilia are a tool of precise energy-saving calculation, the piranha plant's teeth are a piece of pure, effective visual storytelling. The designers took the look of teeth from the flytrap's cilia and gave them the function of teeth from an animal. It is a perfect fusion of botanical inspiration and zoological fear. Even the way the plant is presented in its environment shows a parallel, a kind of ecological echo. The Venus Flytrap is a low-lying plant. Its traps form a rosette that sits very close to the damp, peaty soil of its native bog. It waits patiently on the ground for crawling insects. The flower, interestingly, grows on a very long, tall stalk, called a scape, that rises high above the traps. This is another piece of brilliant engineering. The plant wants crawling insects for food, but it needs flying insects, like bees, for pollination. By physically separating the dining room from the reproductive structures, it avoids accidentally eating its own pollinators. The piranha plant also has a defined territory. It does not live in a bog, but in the iconic green pipe of the Super Mario world. The pipe is its ecosystem, it is its ground. And just like the real flytrap, it sits and waits. It is a stationary threat. In its earliest and most classic form, the piranha plant is an ambush predator, rooted to its spot. The pipe serves the same narrative function as the bog soil. It is the place from which this strange, hungry organism emerges. The verticality is also key. The piranha plant rises up from its pipe, presenting a vertical threat in a game that is all about horizontal movement and vertical jumps. It occupies a specific lane of gameplay space, forcing the player to time their movements around its rhythmic appearance. The long flower scape of the real plant is gone, of course, because the piranha plant has no need to pollinate. Its existence is simpler. Its only purpose, its only biological imperative in its digital world, is to be an obstacle. And this brings us from the visual form to the behavioral algorithm. The deepest connection between these two organisms is their shared strategy, the art of the patient wait. The Venus flytrap is the absolute master of this. It can sit for days, its lobes open to the sky, bathed in sunlight, doing nothing but waiting. It is the physical embodiment of patience. Its entire predatory model is based on letting the world come to it. This passivity is its genius. It expends almost no energy in the hunt itself, saving it all for the rapid snap of the trap and the slow, methodical process of digestion. The classic piranha plant operates on the very same principle. It sits in its pipe, hidden from view. It is not actively hunting the player. It is part of the environment, a living, breathing hazard that operates on its own schedule. It emerges, waits for a moment, and then retreats. It follows a simple, predictable pattern. This transforms it from an enemy you fight into a puzzle you solve. The challenge is not one of combat, but of timing. You learn its rhythm, you watch its pattern. You wait for the opening, the brief moment it has retreated into its pipe, and you run past or leap over. It's a beautiful piece of game design, because it perfectly captures the sit-and-wait essence of the real plant, but translates it into a compelling gameplay mechanic. The plant's patience becomes the player's test of patience. Let's look even deeper, at the trigger mechanism itself. This is where the quiet brilliance of the real plant truly shines. Inside each lobe of the Venus flytrap's trap are several tiny, delicate trigger hairs. They look like little filaments, almost invisible to the naked eye. To close the trap, an insect must touch not one, but two of these hairs in quick succession, usually within about 20 seconds. Or it must touch the same hair twice in that window. This is not a simple reflex, it is a rudimentary form of memory. The plant is using a sophisticated electrical system, not unlike the nerve impulses in an animal. The first touch of a hair primes the trap, generating a small electrical charge that is stored in the cells of the leaf. But it's not enough to spring the trap. The plant waits. It is asking a question. Was that a real insect? Or was it just a raindrop, a piece of falling debris, the wind? If a second touch comes quickly, the second electrical charge is added to the first, and if the combined charge passes a certain threshold, an incredible cascade of events is triggered. Water rushes from the cells on the inside of the lobes to the cells on the outside, causing the leaf to rapidly change from a convex to a concave shape, snapping shut in 1/10 of a second. It is a binary security system. 1 touch means maybe, 2 touches means prey confirmed. This system ensures the plant does not waste its energy on false alarms. Closing and reopening the trap is an enormously expensive process, and a single trap can only do it a handful of times before it withers and dies. The trigger hair system is a masterpiece of evolutionary cost-benefit analysis. Now we turn back to the piranha plant. Does it have a trigger? Absolutely. But its trigger is not biological code, it is computer code. In its simplest form, the trigger is a timer. The game's internal clock dictates that the plant will emerge every X seconds and retreat every Y seconds. The player's role is to observe and learn this clockwork rhythm. In other versions, the trigger might be proximity. The plant only emerges when Mario gets close, creating a zone of danger. But there is a wonderful little detail in the original Super Mario Bros. That adds a layer of nuance. If Mario stands right next to the pipe, or on top of it, the piranha plant will not emerge. It is shy. This little quirk of programming feels, in a strange way, like a nod to the Flytrap's careful nature. It's a rule that gives the player a safe zone, a way to pause and think. It's as if the game designers understood that a relentless, unstoppable trap is less interesting than one with rules, one with a weakness. Just as the Flytrap has a rule 2 touches, not 1, the piranha plant has a rule I will not emerge if you are standing right here. Both are simple algorithms that govern their behavior and make interacting with them a thinking process, not just a reflex test. But here is where the paths of nature and game design must beautifully and necessarily diverge. Evolution is constrained by the laws of physics and biology. Game design is constrained only by the imagination and the need to create fun. And so Nintendo's designers began to take liberties, to break the rules of reality in service of gameplay. The most fundamental divergence is locomotion. The Venus Flytrap is a plant. It is rooted to the earth. Its entire life story unfolds in a single spot. This is its nature. The piranha plant, however, began to move. While its classic form is stationary in its pipe, later games introduced new species. We see stalking piranha plants that can extend their necks to follow Mario. We see puis, piranha plants, that can spit spiky balls while walking around on 2 little root-like feet. We see flying piranha plants, their heads attached to propeller leaves, buzzing through the air. Why this change? Because in a dynamic, side-scrolling world, a stationary obstacle is only one kind of challenge. A moving enemy is a much more complex and engaging threat. It forces the player to adapt, to run, to jump, to react in real time. The designers needed a greater variety of enemies to populate their increasingly complex levels, so they asked a simple question: what if the piranha plant could walk? Biology would say, that is impossible. It violates the fundamental principles of what it means to be a plant. Game design says, that sounds fun, let's do it. The need for engaging play overrides the need for scientific accuracy every time, and rightly so. The second great divergence is the method of attack. The Venus Flytrap's attack is the closing of its trap. Its danger is localized to its immediate person. The threat is contact. After the trap closes, the process is slow and internal. Glands on the leaf surface secrete digestive enzymes, slowly breaking down the soft tissues of the insect over the course of 5 to 12 days. It is a quiet, hidden process. The piranha plant is far more direct. Its attack is a bite. Contact with it causes immediate damage. But the designers didn't stop there. They gave it a projectile. Many variations of the piranha plant can spit fireballs. This is a classic video game trope, a way to extend an enemy's sphere of influence beyond its physical body. A piranha plant that can shoot fire is a threat not just when you are near its pipe, but when you are across the screen. It forces the player to be aware of distant enemies, to weave and dodge projectiles, adding a whole new layer to the gameplay. The slow internal digestion of the real plant was replaced by the fast external projectile of the digital one. The quiet chemical process became a loud, fiery attack. Again, it is a choice made entirely in service of creating a more dynamic and challenging experience. Then there is the matter of scale and environment. Venus flytraps are tiny. A large, healthy trap might be 1.5 inches long. They are delicate organisms living in a very specific nutrient-poor habitat in the coastal plains of North and South Carolina. They are rare and precious. The piranha plants of the mushroom kingdom, by contrast, can be enormous. Some are depicted as being many times larger than Mario himself, colossal heads rising from giant pipes. They are not rare, they are a common feature of the landscape, a natural part of the world's flora. This exaggeration of scale is crucial. A biologically accurate, 1-inch piranha plant would pose no threat to a plumber running and jumping through a level. To be a credible obstacle, it needs to be big. It needs to have presence. Its size communicates its danger just as much as its red mouth and sharp teeth. The hyperbole is part of the art form. The designers have taken the essential concept, a carnivorous plant, and amplified it to mythic proportions, turning a small bog dweller into a monstrous guardian. And finally, we must consider their respective vulnerabilities. The real Venus Flytrap is a fragile thing. It is susceptible to pests, to improper watering, to a lack of sunlight. A clumsy hand could easily damage it. The Piranha Plant, in its world, is often formidable. In the original game, Mario cannot defeat a Piranha Plant by jumping on it, the standard method for dealing with most enemies. It is immune to his most basic attack. To defeat it, he needs a power-up, the Fire Flower, which allows him to shoot his own fireballs, or the temporary invincibility of a superstar. This choice elevates the Piranha Plant. It is not common fodder like a Goomba. It is a specialized environmental hazard that requires a specialized tool to remove. This makes it feel more like a part of the world's architecture than a simple monster. It is a lock, and the Fire Flower is the key. This invulnerability gives it weight and significance in the game's hierarchy of threats, a status the small, real-world plant could never have. So what do we see when we place them side by side? We see a conversation between two forms of design, one natural and one human. Nature, the blind, patient engineer, working through millennia of trial and error, sculpted the Venus Flytrap. Every feature, the trigger hairs, the interlocking cilia, the red lure, the flower on its high stalk, is a solution to a real-world problem. It is a design perfected for survival in a very specific environment. It is beautiful because it is efficient. It is awesome because it is real. Then we have the game designers, the playful artists. They looked at nature's design and saw not a set of solutions for survival, but a set of ideas for play. They acted as creative editors. They took the core concept, the mouth plant, and they copied it. They saw the red interior and the teeth-like cilia, and they exaggerated them, pasting them into their new creation to symbolize danger. They saw the sit-and-wait behavior and translated it into a timing-based puzzle, and then they started deleting and adding. They deleted the need for pollination, the complex trigger system, the slow digestion. They added locomotion, projectile attacks, exaggerated scale, and special invulnerability. They were not trying to create a perfect simulation. They were abstracting. They were capturing the spirit of the Venus Flytrap, its predatory essence, and remolding that spirit to fit the needs of their new interactive universe. The result is a creature that is both instantly recognizable in its inspiration and perfectly suited to its fictional home. The Piranha Plant is a tribute, a loving caricature that honors the strangeness and wonder of the real thing, even as it breaks all of its rules. It is what happens when nature's quiet, ingenious code is rewritten for the joyful, chaotic screen. And it is a testament to the fact that inspiration is not just about copying what we see, but about understanding it and then dreaming it into something new. The bog and the pipe, the leaf and the sprite, are two ends of a long creative journey, a journey that shows just how deeply the patterns of the real world are woven into the fabric of our most beloved fantasies. Chapter 6. The Perils of Fame. Poaching, conservation, and commodification. Breaks all of its rules. It is what happens when nature's quiet, ingenious code is rewritten for the joyful, chaotic screen. And it is a testament to the fact that inspiration is not just about copying what we see, but about understanding it, and then dreaming it into something new. The bog and the pipe, the leaf and the sprite, are two ends of a long creative journey, a journey that shows just how deeply the patterns of the real world are woven into the fabric of our most beloved fantasies. But that journey, that deep weaving of the real into our shared dreams, comes with a strange and sometimes heavy price. When we love something, when we are truly fascinated by it, our first, most human impulse is often to draw it closer, to see it for ourselves, to own it, and when a creature as singular as the Venus Flytrap becomes an icon, a celebrity in the kingdom of plants, that collective desire can become a powerful and dangerous current. This fame, born of its bizarre genius and amplified by our digital worlds, has cast a light so bright upon the flytrap that it has also cast a profound and troubling shadow across its only home. To understand this shadow, we have to leave the glowing screen behind and travel to a very specific place on Earth. Let's go there now, in our minds. Let's find ourselves standing in the coastal plain of the Carolinas, a place where the air is thick with humidity and the sweet resinous scent of longleaf pines. The ground beneath our feet is not rich, dark soil, but a pale, sandy loam. It's a landscape that, to the untrained eye, might seem sparse. But look closer. Between the towering pines, the ground is a carpet of wiregrass, pitcher plants, and delicate orchids. This is the savanna, a world sculpted by lightning and fire, a habitat of subtle and ancient beauty. And here, in the damp depressions and boggy margins, is the only place in the entire universe that the Venus Flytrap calls home. It is a remarkably small kingdom for such a famous ruler. A tiny postage stamp of territory, a mere 90-mile radius around the city of Wilmington, North Carolina, is the flytrap's entire native world. For a species known globally, its anchor to this planet is startlingly local and terrifyingly fragile. And it is here, in the quiet of the pines, that the shadow falls. Imagine a figure moving through this landscape at dusk. They are not a biologist or a hiker. They move with a quiet, efficient purpose, carrying a small shovel or a trowel. They are not here to admire. They are here to take. This is poaching, and for the Venus Flytrap, it is a persistent and devastating threat. To you or me, the plant is a marvel of evolution, a tiny living sculpture. To a poacher, it is a commodity. It is a few dollars in a plastic pot, multiplied by the hundreds or even thousands that can be dug up in a single afternoon. The act itself is a quiet violence. The shovel cuts through the delicate black roots that anchor the plant to its world. It lifts the entire rosette, soil and all, from the only home it has ever known. A lineage that has survived in this exact spot for millennia, perfectly adapted to this acidic, nutrient-poor soil, is severed in a matter of seconds. And the empty space it leaves behind is more than just a hole in the ground. It is a tiny, silent erasure. When thousands of these erasures happen, the fabric of the ecosystem begins to unravel. The wild population, already under pressure, shrinks. Its genetic diversity, the very library of resilience that allows it to adapt and survive, is stolen, page by page, and sold by the roadside or online. It is a crime born of a profound misunderstanding of value. The poacher sees a price tag but misses the incalculable worth of a life form that exists nowhere else. In response, the state of North Carolina has had to turn this quiet botanical theft into a serious crime, a felony. Park rangers and conservation officers now patrol these areas, not just for threats to bears or deer, but for the silent thieves who come for the flora. They are guarding a treasure that is so small you could hold it in the palm of your hand, yet so significant it has captured the imagination of the entire world. It's a strange duty to stand guard over a plant, but it speaks to the severity of the love we bear it, a love so intense it has become a threat to its own survival. But poaching, as personal and damaging as it is only the most direct threat. A far larger, more insidious pressure comes from something we all participate in, often without a second thought. It is the simple, relentless expansion of our own world. The specific conditions the Venus Flytrap requires are what a biologist would call unforgiving. It needs the poor, waterlogged, acidic soil of the bog, because paradoxically, it is an environment with almost no competition. Most other plants can't survive there. It needs the wide-open canopy of the longleaf pine savanna, a forest that allows bright, direct sunlight to reach the ground. And most surprisingly, it needs fire. For thousands of years, this ecosystem was shaped by regular fires, often sparked by lightning strikes. These fires would sweep through the undergrowth, clearing out the shrubs and hardwood saplings that would otherwise grow up and shade out the sun-loving flytraps. The fire is not an agent of destruction here, it is an agent of renewal. It is nature's way of clearing the clutter, of resetting the stage, so that its most specialized performers, like the flytrap and the pitcher plant, can have their moment in the sun. It is a brilliant, counterintuitive piece of ecological engineering. But as human settlements have expanded, our priorities have changed the landscape. We build roads and houses. We drain the wetlands that feed the bogs, turning them into farmland or subdivisions. And for very understandable safety reasons, we suppress fire. We see a forest fire as a disaster to be stopped at all costs. But in doing so, in protecting our world, we inadvertently dismantle the fly traps. Without the periodic fires, the undergrowth thickens. The shrubs and oaks grow tall, their leaves creating a dense canopy that casts the forest floor into deep shade. And in that shade, the Venus Flytrap, a creature born of and for the sun, slowly, quietly, starves. Its home shrinks. What was once a contiguous stretch of pine savanna becomes a series of disconnected islands, surrounded by a sea of development. A flytrap on one of these islands has no way to reach another. Its population becomes isolated, its gene pool stagnant. It is like a city whose highways have all been cut, leaving its residents unable to travel, to meet, to create a healthy and diverse future. The threat is no longer a single person with a shovel, but a bulldozer. It's the slow, creeping change of a world that is becoming less wild, less suited to the strange and beautiful outliers of evolution. It is a bleak picture. It is true. But to tell only this part of the story would be to miss the other side of our complicated relationship with this plant. Because for every person who seeks to take from the wild, there are others who have dedicated their lives to protecting it. They are the quiet guardians of the bogs. These are the conservationists, the ecologists, the botanists, and the passionate volunteers who work to turn back the tide. If you were to follow them into the field, you would see a very different kind of human interaction with the flytrap. You would see people on their hands and knees, not with a trowel, but with a notepad and a measuring tool. They are meticulously counting the plants, mapping their locations, assessing the health of each population. They are conducting a census of a silent kingdom. You would see them working with land trusts and nature conservancies to purchase and protect the last remaining tracts of pristine savanna. These protected lands become sanctuaries, arks of biodiversity where the ancient rules of the ecosystem can still apply. And here they practice what is known as ecological restoration. They become the agents of the forces the flytraps need to survive. They carefully reintroduce fire to the landscape, in what are called prescribed burns. With incredible planning and skill, they set controlled, low-intensity fires that mimic the natural lightning strikes of the past. You can smell the wood smoke for miles, a scent that for the flytrap is not a warning but a promise of sunlight, a promise of open space, a promise of renewal. The conservationists are, in a very real sense, gardeners on a landscape scale, tending to one of the planet's most remarkable wild gardens. They also work to restore the natural flow of water, healing the scars of past drainage ditches, and in the most damaged areas, they undertake the delicate process of reintroduction. They grow genetically diverse flytraps from wild collected seeds in protected nurseries, and then with the care of a surgeon, they plant these young seedlings back into the restored bogs, hoping to stitch the fragmented populations back together. It is slow, patient, and often thankless work. It is an act of profound ecological apology, an attempt to mend what we have broken. And it is a testament to the fact that our fascination can also fuel a deep and powerful sense of stewardship. But this brings us to the final, and perhaps most bizarre chapter in the modern story of the Venus Flytrap. It is a paradox that exists at the heart of its fame. While these conservationists fight to protect the last few thousand wild individuals in the Carolinas, you can walk into a hardware store or garden center almost anywhere in the world, in Tokyo, in Berlin, in Sydney, and you can buy one for the price of a cup of coffee. The Venus Flytrap is, simultaneously, a critically vulnerable species and a mass-marketed global commodity. This is the world of horticultural cultivation. For decades, growers have been propagating the Venus flytrap through tissue culture. In sterile labs far from the Carolina bogs, a single sliver of plant tissue can be used to generate thousands upon thousands of genetically identical clones. These are the plants you find in little plastic cubes on the shelves of supermarkets. They have never known the feel of Carolina soil or the taste of a wild insect. They are born of agar and fluorescent lights. This industrial-scale propagation has, in one sense, been a huge benefit to the wild populations. It provides a cheap, accessible, and legal supply of plants, which dramatically reduces the incentive for poaching. Why risk a felony to steal a wild plant when you can buy a perfectly healthy, lab-grown one for $5? In this way, the nursery has become a kind of shield for the bog. But it has also done something else. It has turned the fly trap from a wild animal into a domestic one. Humans have taken over the process of its evolution. Breeders and hobbyists around the world select for unusual traits, creating a dazzling array of what are called cultivars. There are fly traps with giant traps, like the Boar 52. There are fly traps that are a deep blood red all over, like a Kai Ryu. There are some whose trigger hairs have fused into menacing-looking teeth, like Sawtooth, and others whose traps are fused shut or comically misshapen. We have become the agents of its natural selection, guiding its development not by the pressures of survival in a bog, but by our own aesthetic whims. We have taken nature's brilliant but frugal engineer and handed its blueprints over to a team of wonderfully eccentric artists. The result is a plant that is still recognizably a Venus flytrap, but it is also something else, a living reflection of our own creativity and our desire to customize the natural world. And this is the central confounding irony of the flytrap's fame. Does its celebrity ultimately help or harm it? The answer is not simple. Its fame drives the poachers who threaten it, and the developers who unknowingly pave over its home. But that same fame inspires the conservationists who protect it, and it fuels the horticultural industry that provides a safe, alternative supply. The little plant in a pot on a child's windowsill might spark a lifelong passion for biology, creating the next generation of conservationists, or its very commonness in cultivation might make us complacent, tricking us into believing it isn't really endangered in the wild at all. How can it be rare, we might think, if I can buy one at the store? The Venus flytrap, in the end, has become more than just a plant. It has become a mirror. It reflects our own complicated, contradictory nature, our capacity for careless destruction, and our capacity for dedicated preservation, our impulse to possess and our impulse to protect, our reverence for the wild and untamed, and our endless desire to tinker, to breed, to reshape life into new and fantastic forms. It sits at the nexus of all these things, the wild bog and the sterile lab, the video game sprite and the poached specimen, the conservationist's data sheet and the hobbyist's prized cultivar. It carries the weight of all our projections, all our fascination, all our love, and as it does, it continues its silent, patient existence, trapping the sun on its strange green leaves, waiting to see which side of our nature will ultimately decide its fate. Chapter 7. Chapter 7. Entangled Legacies, How a Plant and a Pixel Defined Each Other. And perhaps that is the most curious part of our nature, the part that decides its fate. We are not content to simply observe. We have this deep, ancient and insatiable need to interpret, to take the raw, unfiltered code of the universe and translate it into stories we can understand. We see a cluster of stars, and we paint a hunter, a bear, a queen. We find a fossilized bone, and we imagine a dragon, and we see a tiny green marvel of evolution in a Carolina bog, a plant that eats animals, and we create a monster. For countless of us, our first encounter with a carnivorous plant wasn't in a science textbook or on a nature documentary narrated by a calm British voice. It was on a flickering screen, accompanied by cheerful 8-bit music. It wasn't Dionea muscipula, it was the Piranha Plant, a bold, simple, and brilliantly effective creation of red and white, popping up from a green pipe, its cartoonish teeth chomping at the air. It was an obstacle, a charmingly persistent threat in a digital world of mushrooms and castles, and in performing that simple function, it did something extraordinary. It became an ambassador, an unintentional park ranger for the entire world of botanical carnivory. Before we ever learned about trigger hairs, digestive enzymes, or the delicate balance of a coastal plain ecosystem, we learned a more fundamental lesson. Some plants bite back. This is the beginning of the great feedback loop, the strange and beautiful entanglement of the real and the imagined. The Venus flytrap, in all its quiet biological genius, provided the spark. A game designer, tasked with creating memorable and intuitive challenges, saw in that snapping trap a perfect universal symbol for danger. Nature, the patient engineer, had crafted a marvel of hydraulics and electrical signals designed to catch a fly. The game designer, a storyteller working in the language of pixels, needed a shorthand. He didn't need the nuance of the 6 triggers, the slow seal of the trap, the week-long digestion. He needed the idea of it, distilled to its absolute essence, a mouth that emerges from an unexpected place. And so, the Piranha Plant was born. A caricature, yes, an exaggeration, but all the most powerful symbols are. It took the flytrap's most alien quality, its animal-like behavior, and amplified it. It gave it bold colors, a stalk like a serpent's neck, and a home in a pipe, an artifact of an industrial world which only made it feel more uncanny, more out of place. It became for millions of children the mental blueprint for what a carnivorous plant is. This blueprint is so powerful that it has in a way begun to overwrite the original. When you ask a person to draw a man-eating plant, they will almost never draw a scientifically accurate pitcher plant or a sundew. They will, more often than not, draw something with a distinct head, a stalk, and a mouthful of sharp triangular teeth. They will draw a piranha plant, whether they realize it or not. The fiction has become the default. You can see this tangled legacy everywhere you look. Walk through a pop culture convention, a comic book store, or simply browse online. You will find Piranha Plant merchandise in abundance. There are plush toys, soft and cuddly versions of a creature we once found threatening. There are lamps, their spotted heads glowing with a warm, comforting light. There are slippers, desk organizers, and sculpted figures. Think for a moment of the desk of a fan. On one side, in a small terracotta pot, sits a real Venus flytrap. It requires distilled water, bright sunlight, and a period of winter dormancy. It is a living, breathing organism, a delicate piece of biological machinery honed over millennia. And on the other side of the desk, a plastic piranha plant puppet sits, its goofy grin perpetually fixed. The two are neighbors, the real and the hyper-real, coexisting. The toy does not need water or sun. It does not die from improper care. It is a perfect immortal effigy of the living thing beside it. This is where the lines truly begin to blur. The piranha plant has domesticated the idea of the Venus flytrap. It has taken this strange, slightly unsettling creature from the wild bogs and turned it into a familiar, even beloved character. It has made the concept of a carnivorous plant accessible and non-threatening, and in doing so, it has opened a door. A child who loves Mario and his strange cast of enemies might see a real Venus flytrap for sale at a hardware store and feel a spark of recognition. It's a piranha plant, they might think, and a connection is made. A seed of curiosity is planted, not in soil, but in a young mind. That curiosity can lead to a Google search, a book from the library, a documentary. It can lead to a genuine, lifelong passion for botany. The pixel becomes a portal to the plant. But this fame is a strange and powerful current, and it flows in both directions. For every person whose interest in botany is sparked by the game, there is perhaps another for whom the plant becomes a disposable novelty. The game creates an expectation of action, of cartoonish chomping. The reality is one of stillness, of immense patience. A real Venus flytrap might only catch a few insects a month. It moves with a slowness that can feel anticlimactic to a mind accustomed to instant gratification. And so the popularity driven by its digital cousin can lead to a wave of impulse purchases. Plants are bought, given improper tap water, placed in dark rooms, and fed things they cannot digest. They are treated not as the specialized, sensitive organisms they are, but as toys that have failed to perform. Their slow death on a windowsill is a quiet testament to the gap between our expectations, shaped by fiction, and the delicate truth of nature. The piranha plant, then, is a modern piece of folklore. It is a digital cryptid. For generations we told stories around the campfire about creatures that lurked in the woods or in the deep waters. We translated our fears and our respect for nature into the forms of werewolves, dragons, and krakens. These creatures were born from glimpses of the real: a wolf's howl, a dinosaur fossil, the tentacle of a giant squid. They were explanations, warnings, and expressions of awe. The piranha plant is a creature of that same tradition. It is folklore for the screen age. It is born from a real organism, translated through a new medium, and it serves a similar purpose. It teaches a simple, primal lesson. The world is full of surprises, and not everything is as it seems. Even the plant world has its predators. As we stand back and look at the whole story, from the sandy soils of North Carolina to the circuit boards of Kyoto, we see this incredible looping narrative. A humble plant, through its sheer biological strangeness, inspires a work of art. That work of art becomes a global icon, so famous that it reshapes how humanity perceives the original plant. That new perception in turn influences the real-world fate of the plant, driving conservation conversations and hobbyist markets, for better and for worse. Reality informs fiction, and fiction reinforms our reality. It's a humbling thought that this small plant, with no brain, no consciousness, no awareness of its own fame, has had such a profound cultural impact. It has been immortalized, not just in scientific journals and conservation databases, but in the shared memories of billions of people. Its legacy is now twofold. There is the legacy written in its own DNA, a story of survival against the odds in a nutrient-poor world, a legacy of exquisite adaptation, of traps that count, and of a silent, sun-powered existence. This is the legacy that lives in the dwindling longleaf pine savannas, the one that whispers in the wind that rustles through the wiregrass. It is the truth of the organism. And then there is the other legacy, the one written in pixels and code, in plastic and paint, in the joyful memories of navigating a digital kingdom. It is a legacy of pop culture, of a monster that became a friend, of a piece of nature that became a piece of our collective story. In the end, after all the analysis, after all the pixels have been rendered and all the toys have been manufactured, the Dianea muscipula itself remains, indifferent to its own myth. It sits in the cool, damp air of the bog, its emerald jaws held open to the sky. It feels the warmth of the sun, the vibrations of a fly's wing, the gentle touch of the rain. It knows nothing of its red and white doppelganger, nothing of the princess or the plumber. It simply continues its slow, patient and magnificent cycle of life, a silent testament to the fact that the most incredible fictions we can ever imagine often pale in comparison to the truth of what is already here. One made of light and code, destined to be remembered, and one made of sunlight and water, content only to be.